Hi, this is Anthony, and today we're going to start talking about Solidworks Assemblies. So far within the class we've been talking about, when we go to make a new part, you can Control N or File, New. We've been talking about parts. Well, we haven't talked about assemblies or drawings yet. So today we're going to start talking about assemblies. So assembly is like it says here, is a 3D arrangement of parts or other assemblies within SolidWorks. So it's basically a collection of parts. And more importantly, it's information about how the parts or sub-assemblies interact with each other. It allows you to make like a working device. So let's say we want to make a gearbox. Then in order to put the parts together, we're going to have to make an assembly. So we'll draw each gear separately, like the housing separately, and then we will what's called mate them together, or tell how they arrange together in three-dimensional space. It's similar to a part file in that there's a top, right, and front plane. So if I go to SolidWorks and say make a new assembly, we're going to see that there's similar information over here to the part files. So we have the front, top, right, and origin, just like we do within a part file. Okay, so click the assembly, front, right, and top plane. So before we get too far into an assembly, we're going to make a part that lets us demonstrate how assemblies work. So I'm going to draw a simple L-shaped bracket. So I'm going to use my mouse gestures and go to the left. I'm going to draw a simple symmetric part. I'm going to enforce equality relationships between these lines here, also between this line and this line. These have to be equal. So by doing that, then I should be able to maybe one more relationship, this one and this one. So those are equal. Then I can smart dimension this, and now the sketch is fully defined, which is what we want. Interestingly, by setting it up in this way, if I change this value, it's just going to scale up or down the size automatically by changing a single parameter. So I'll make it 6 inches. Now I'm going to extrude this 2 inches. Then I'm going to go to File, Save, or Control S. It's the shortcut that I can do. Next I'm going to go to this folder that I put on my desktop. So I made a new folder on my desk called In Class, and then I made one for assemblies. Then I'm going to give it a meaningful name and save this as a part file. So let's call it L shape part, and I've saved it on my computer. Now let's go to the assembly again, and I want to insert that part into my assembly. So the first thing we need to know is that in order to insert something, it has to be saved on your computer, at least in general. There's a few kind of exceptions, but that's not the primary way. So that's why I saved the previous part file. Next, I'm going to go to this insert component right here, and I have a few different options. So there's two ways I can place a part in assembly. One, I can select the part to insert by looking at my open documents. So right here, this is showing that I have the L-shaped part open within SolidWorks right now, and I can insert it if I want. Also, the second way is I could browse on my computer for like previous parts that we've made in the class, and either method is fine. So we'll click on Insert Component, and then we have the two different options. So let's say we want to insert more than one component. To do that, we're going to push this push pin, keep it visible push pin, and that will let us place multiple copies of a single part, or if you want to insert one part and then select something else, it'll keep this insert component tool open for us so that we can easily place another part. So that's what I'm talking about here, to place a part. If we want to insert more than one part, we're going to push the push pin as though we were trying to like push into a cork board on a wall and keep this tool open. Okay. So the next question is, where are we going to place it in space? Now, the problem that we have is that to describe a location in three-dimensional space with the mouse is difficult because we don't have depth information on a 2D screen. This is the same reason, like we talked about before, why it's difficult to make three-dimensional sketches. Why we, in general, we prefer making a 2D sketch on a plane. It's because there's some ambiguity about where the mouse is actually located in 3D because it's on a 2D screen. There's no information about the depth. So we have the same problem when inserting an assembly. It's not clear where it's actually going to be located. So we have two main options. The first one is if I click this green check mark. Okay, so if I click the green check mark, it's going to make the origin of the part and the assembly coincidental, and it's going to make it so that the top of the assembly and the top of the part, those top planes align. The right plane of the assembly and the right plane of the part align, and the front plane of the part and the front plane of the assembly align. So I'll show you what I mean. So I'm going to click OK. So it's placed the part. I'm going to exit my Insert Component tool. Now let's take a look at this part. So first I'm going to turn on the view planes. And then I'm going to make these planes visible for my part. So just like within a SolidWorks part, there's features. The features of an assembly are primarily going to be the parts or sub-assemblies that make up the assembly. So, and just like we can click on this little arrow right here to see like the sketches or profiles used to make a feature, we can do the same type of thing and see what's within this particular part. So I made visible the 3 planes of this part. I can do a similar thing for the assembly. So let's take a look at this. Here's the front plane of the assembly right here. Let me turn off the visibility of these other 2 on the part. And look at where the front plane of the part is. The front plane's here. On the part, the front plane of the assembly is right here. You see how they're lined up. They're right on top of each other. The same has happened with the top plane of the part in the assembly. So the top plane of the assembly is right here. The top plane of the part is right here. They're right on top of each other. The same is true with the right plane as well. So the right plane of the assembly is right there. Right plane of the part is right there. And when we align the planes in that way, it happens that the origins will, by default, must also line up. So the origin of the assembly is right here, and the origin of the part is right here. The key thing is that when I click this green check mark, it's going to automatically do that. It's going to automatically align the top right and front planes of the assembly and the part. And then when it does that, the assembly's origin and the part's origin will also be coincidental. So our second option when inserting a part is we can just place it generically anywhere in 3D space. So instead of clicking the green check mark, this time I'm just going to click somewhere. Okay, I want to insert multiple copies, so I'm going to insert the push pin, keep visible, and select this one. So if I just click somewhere, then it's going to be placed. So for example, I'm going to try to place this next to that one. And you can see it looked like when I first clicked that it was right next to it, but in reality it's behind it. And again, that's the difficulty with trying to describe a point in 3D space using a mouse, is that we don't have depth information. It makes it a little bit tricky. We can also do things like this. We can rotate the part by clicking these buttons. So let's say I want to make it so it's like a puzzle. So these interact, or they're going to fit into each other, and I can rotate it into the orientation that I need. So that's what we're talking about here. When we place an assembly, we can place it freely by just clicking, and we can rotate, use these buttons to rotate it, and then just click. Now, within sketches, we've been talking a lot about how it's very, very important that our sketches are fully defined. If it's not fully defined, the chances of it actually being the correct shape are slim. And a similar idea with assemblies, that we want to make sure that we've given the assembly enough information to actually know where all the parts are located. So we're going to have to give it a lot of relationships. Also, we need something to be, and there's this idea of fixed and float. So something that's fixed in 3D space, it can't move. So let's take a look at this one. I can drag this around and it moves freely. This one moves around freely and this one moves around freely. So it's not fully defined in 3-dimensional space. Like, it can go anywhere. This one, I try dragging it and it can't go anywhere. And look at, there's this little message popping up saying the selected component is fixed and it can't move. So what that means is that when something is fixed, right here has this F in front of it, it means that Solidworks is just keeping its 3-dimensional spatial information constant, and it will not be allowed to move. Oftentimes, though, we want to make it so something can move in 3-dimensional space. So how do we unfix something? So to do that, we just do a right click on the part, and then we're going to go to float. So now, once the part is able to float, you see that the F over here is gone, and now I can drag it around. So now that it's floating, let's say I want to fix it. I just do a right click on this part and can go to fix. Now it's stuck. You can't go anywhere. Okay? So when you see this little F right here, it means that it's fixed. It's probably a little unfortunate that fixed and float both start with F. But if you see the F, that means fixed. It cannot move. When something can float, it can move around. It can probably move around. Like, if I give it enough relationships to a fixed part, it might not be able to move around. I will talk more about that in a few minutes. So the general rule is that we don't want assemblies to be able to translate in 3-dimensional space. Unless the whole assembly should not be able to relate. Like maybe a component, like a slider or something, and if it's like on a linear track, it might be able to move, and that's like the actual function of the part, and that's fine. But in general, the whole assembly itself should not be able to translate or rotate in 3-dimensional space. So something needs to be fixed or mated to the top right and front plane of the overall assembly. So the next big idea that I got past fix and float is mates. Mates tell how the parts interact. And they're very similar to relationships within a sketch. So there's like coincidental, parallel, orthogonal, locked. We haven't talked, I don't know if there's an equivalent of locked in a sketch. We can do distance, angle, and there's quite a few more. These are that are unique to assemblies that have no parallel with sketches. So let's start playing around with that. So let's fix this one, this part. So now it can't move. I'm going to float this one, so now it can move. So let's say I want to mate them so that they're touching each other and they're fitting together like a puzzle piece. To do that, I have to tell it what two parts of the geometry from two different parts I want to add a relationship between. So in this case, I want this face and this face to line up. So to mate them or add a relationship, I'm going to select one face, or I can just click on mate and then do it. So you're going to find that just like with relationships within sketches, there's like 10 different ways to quickly add a relationship. Same as with mates. There's about 10 different ways that we can add a mate between components. Some are faster than the others, and hopefully as you get more comfortable with SolidWorks, you'll be able to use the faster options. I'll try to use the most basic options right now, most basic ways, so I don't confuse you by doing some shortcuts. So I'm going to click mate. I'm going to select this face. So over here you see mate selections or entities to mate, and I want to mate that front, this face right here of this part, and then have to select another part, a face on another part, or a feature on another part that I want to add a relationship between. So I'm going to select this face. And you can see that by default it's added this coincidental mate, meaning that these two faces are now going to line up. The planes that are defined by the face are coincidental, meaning they line up. So I click OK. Next, I want this plane that's defined by this face and this face to also line up. So I'm going to click OK. You see how, just like within a sketch, when we add a relationship, it can change the geometry to enforce the relationship. The same type of thing is going to happen within an assembly where I tell it to mate, and then it's going to move the components in order to enforce that particular type of mate. Click OK. Next, I want this face to touch this face. And see, by default, it's added the coincidental. Let's say if I do something like parallel. It's okay if these are parallel. It's okay that they have a distance between them. The parallel mate basically enforce that they can't rotate with respect to each other, so that the planes like cross in any way. I'm gonna try perpendicular, but then it says if I select perpendicular, then it's going to break other mates. Like it's not possible to enforce the other mate relationships while being perpendicular. So I'm just going to stick with coincidental because we want to line up. And there we go. So I've mated these two together. Now this is interesting what I was talking about before. This part right here is fixed. I can tell because it has this F. This part is not fixed. There's no F. But it can't move. And the reason is that when this one is fixed, the relationship between these two parts is fully defined, so that this part, there's no ambiguity about where it is in three-dimensional space, because we know exactly how it's going to be with respect to another fixed part. So it's making this like chain of relationships that specify its position. Okay. So I'll show you another way that we can mate things together. But before that, I'm going to show you how to rotate parts. So it's really easy to drag parts around. In fact, as I drag, you'll notice at the top right here that as I drag it, this move component button is kind of like being depressed automatically. But let's say we want to rotate things in space. This actually turns out to be really helpful. We'll talk about that in a minute. So I want to rotate this one so it almost fits or complements this one. So just like these two fit together, I want to rotate this so that it fits into the other one. So I'm going to go, instead of just moving it, I want to rotate it. So I'm going to click on the drop down right here and go to rotate component. Then as I use my left mouse and I do the similar motion for changing my view, similar kind of rotating feel that I use for rotating my view, I'm going to use that same motion in order to rotate the part. Once I'm finished rotating, I click OK. Now I want to move it over. Make it so that the two parts are almost in the correct position with respect to each other. We're going to talk about why you might want to do this in a few minutes. Okay, so I showed you before how we can just click mate and then select the two faces. Now the fast and easy way to mate something is just to select both parts or both features that we want to mate at the same time by holding down Control. So I'm going to select this face and this face at the same time by holding down Control, and then give it the coincidental mate in a little pop-up menu. I'll do it again. I'm going to select this face. I'm going to hold down Control, select this face, move my mouse slightly up and to the right, and then the pop-up menu will show. Then I can click coincidental. And finally, I want to mate this face and this face. So I'm going to hold down Control again, move my mouse slightly to the right and up, select coincidental. Okay, and that will make mating go much faster for you. There's other things we can do to speed up mating, but by far just holding down Control, selecting multiple things, just like we did within a sketch, allows us to easily add relationships or mates. So what are the two most difficult concepts that students have with assemblies? First is a misunderstanding of what exactly an assembly is. And the second is how do you place and orient parts within an assembly with respect to the overall assembly. So first we're going to tackle the first problem. What is assembly? One more thing before we actually get there. I'm just going to go ahead and make this part, this phase, this one. I'm going to make one complete one object that's so that all these pieces are put together. And one more small thing before we get started, just like within a part we can go back and edit a feature, we can do the same thing within an assembly. So if I want to go back and change a mate, I'm able to do that by clicking right here off to the left on mates, and I click the little arrow, and then I can see all the mates that are used within this particular assembly. So let's say, like, oh, I made a mistake on this one, I want to go back and edit it. I was going to click on the mate, go to edit feature, and then I'll be able to see all the information and options available for me to change for this particular mate. So again, that's pretty much exactly the same as what we did within a part file, where we can go back and edit features. The key thing is that the information is right here underneath of mates. Okay? Alright, so back to our PowerPoint presentation. So what exactly is assembly? This is one of the most common problems that students have. So an assembly is a description of relationships between parts. It is not the geometry itself. It is only a description of the relationship. So in our example that we've been doing, like we've made this phase to this one, and maybe this phase to this one, the assembly contains information about the relationships. Like it's the arrows here. But these relationships are meaningless unless they have something to relate to. So the relationships by themselves are meaningless without the part file geometry. So when we send someone an assembly, or when you send something to me for grading, you absolutely must have the part files along with it, or else it's not going to work. And I'm going to show you exactly what I mean. So I've made this assembly. I'm going to go ahead and save it. So I'll just call it assembly sm1.sldasm. You'll see that there's a different type of file. It's an assembly part file. It's assembly Solidworks file. So I'm going to save that. Now I'm going to close Solidworks. I'm going to go to this folder. So here's the folder. Here's my assembly one and my L-shaped part. Let's say I make a new folder. I'm going to call this parts. And I move this I move this L-shaped part into my parts folder. Okay. So what that did is it changed the relative path from the assembly to the part file, and now SOLIDWORKS is not going to actually know where it is. So we'll see what happens when SOLIDWORKS doesn't know where the part file is. So now if I relaunch SOLIDWORKS, the reason why I had to close SOLIDWORKS is that in general SOLIDWORKS will try to prevent you from making mistakes like this. So by moving the part file into another folder, SOLIDWORKS can no longer find it, and this is what it looks like. So again, the key idea is that SOLIDWORKS is, within SOLIDWORKS, an assembly is a description of relationships. It's not the geometries itself. So when SOLIDWORKS cannot find the geometry, this is what your assembly will look like. And you can imagine this is not going to get a good grade. It's going to get a 0 because there's nothing here. Okay, so it's essential that you have the part files, that you include the part files whenever you turn in an assembly. And sometimes we're not going to explicitly tell you every single time because we expect you to understand that you have to turn in the parts. But anytime you send an assembly, you absolutely must have those part files as well. Okay, so it's like these arrows. The assembly is the arrows. It's the relationships, but it's not the parts themselves. So let's say we have this. how are we going to fix the problem? Like you might accidentally do this sometime while working on complex assembly. If we want to fix it, what we can do is go to File and go to Replace. Then we have to select the component we want to replace. I want to use this one, the L-shaped part. Then I want to replace it with this one, the with this one box. So I have to browse to where it's located. Here it is, L-shaped part. Then click OK. Click yes, yes. Then it's going to ask me about mates. Click yes. Now, even though I've replaced it, everything is still blank, and that's because I need to unsuppress the part, because by default, anytime it can't find a file, it's going to suppress it. So we need to unsuppress it. So I'm going to go through and unsuppress these. And as I do, they should appear back within my assembly. Okay, so now we're back in business. Everything is okay. So I just did Control S to save this so that it will work in the future. Okay, so I went to File, File, Replace, the File menu, and then went down to Replace. Then I used the Replace tool to select the component. So in this case, it's the L bracket. I browse to where it's located on my computer and then click OK. And then I'm going to have to unsuppress each part. So that's the problem. How am I going to fix it? The first thing is that if you're not sure if the whole idea of like relative paths bothers you, and you're not comfortable with computers maybe, the easy solution is if your part and your assembly are in the same folder, everything will be okay. As long as you don't rename the parts. So don't rename your parts after you've made them and put them into your assembly. And also, just make sure that they're in the same folder. Otherwise, the relative path to the parts needs to be the same. You can't change the relative path because that's how Solidworks is trying to find where it's located. And also, if it's working on your computer, it doesn't necessarily mean it's going to work on my computer. If you change the relative path, Solidworks, the part itself, this assembly will still have like absolute path information available that it might be able to use on your computer. So there's a chance that opening on your computer will be okay, but if you've changed the relative path, it won't open on someone else's computer. So when you turn in an assignment, you're going to have to zip together the folder with the parts and the assembly to make it work. So I'm going to close this assembly file. So here's my folder, assembly. I have my assembly 1, and within this I have a part. So if I wanted to turn this in, I would zip together this whole folder by doing a right click on assembly, and go to send to, and say compress zip file. There we go. So within this zip file, I'm going to have the SM1 and also the subfolder parts. Within the parts, I'm going to have my L-shaped part. So when we go to grade the part, or grade the assembly, we'll unzip it, and it will still have this same file structure with the assembly and the parts having the same relative path on my computer, so therefore it'll open correctly. So it's really key that you don't change the relative path and that you zip it together correctly, or else it's not going to open when we go to grade the file. So this is what I was showing. We can zip together the folder containing everything, and then it'll all work. So the second big issue that students have is they have a hard time sometimes understanding how to place and orient parts within an assembly. So let's go back to this assembly that we had, SM1. And the first thing that we haven't talked so much about, because it hasn't been a big deal so far in the class, is this triad right here. So we have this X, where X is right here, X, Y, and Z. Actually, you can click on these arrows. So I click on X, and it's going to change my view. So I'm looking at it in that particular orientation. Let's say that I want to make it so this edge is pointing in the positive, is pointing along the x-axis. So right now you can see that this edge is going up and down in the y direction. So how do I change the orientation? Students have a hard time with this general idea. So I'm going to show you. So first thing we want to do is I want to change the orientation assembly. I have to look at this triad and make sure I understand which direction it's pointing right now. Next, I need to make sure that all my parts can move, because if I want to change anything right now, it's not going to work, because I can't move anything. So I need to make it so that my parts can move before I start trying to play around with things. So the reason why I can't move right now is because this part right here is fixed. I can tell because it has this F. These other ones are fully mated to this part. You can also see down here, just like within a sketch, where it says fully defined or not fully defined, it says this assembly is fully defined. So in order to move the assembly and change its orientation, I need to make it so this part can float, so it can move freely. So I'm going to right click on it and go to float, like we did, like I showed earlier, and now it can move around. Okay. So I'll make sure it can float. Next, I want to view the planes. Make sure I understand where my planes are located. So let's view our planes again. Okay, I'm going to I'm going to open my part. So this is a shortcut on how to open a part quickly. So if I want to I could go to File, Open Recent, and go to my L-shaped part. Also within an assembly, if I just click on it and go to Open Part, then I can very quickly open the part that's contained within my assembly. Also, within Solidworks, we've been, for your homeworks, you might have multiple parts, and they aren't necessarily related, so you could work on one after another so far within class. But now that we start getting into assemblies, your parts are dependent upon each other, and you might need to switch between a part file and an assembly file relatively often. So this is what most students have been doing. You just like hover over the Solidworks icon over here, and you see we have L-shaped part and we have assembly open. But that's perfectly fine. There's nothing wrong with that. There's some other ways that we can toggle between our different open Solidworks documents. One is if I go to Window, then I can see all my open documents right here. Also, if we wanted to, we could make it so both are visible, or we could tile our open documents. I am personally not a fan of that at all. I don't find it helpful. But some people really like it. It's totally up to you. I like just having one file in front of me at a time. Next, the next way that we can change which part we're looking at or which document we're looking at is I can do something that's kind of similar in Windows. Windows, if I do Alt-Tab, that's what I've been doing in this presentation to switch between PowerPoint and SolidWorks. If you didn't already know that, that's a quick shortcut for you within Windows. You can use Alt-Tab. Within SolidWorks, there's something similar. If I hold down Control and hit Tab, it's going to bring up this document. Now, right now, you can't see, but I'm holding down the Control key. And then every time I hit Tab, it's going to toggle between the two open parts. Then when I let go of Control, it's going to actually go to that part. So very quickly, I can just hit Control Tab, and then let go. And that allows me to extremely quickly switch between my documents that are directly in front of me, which turns out sometimes to be like really helpful. Okay, so that's how once you start getting into assemblies that have multiple parts, that'll turn out to be pretty helpful for you to be able to quickly switch between which document you're actually looking at. Okay, so now I have my assembly and I'm looking at it. My assembly's front plane is right here, the top plane's right there, and the right plane, I'll make that one visible as well, as right there. So I was saying earlier that I want this edge to be pointing in, or which edge was it? It goes this edge actually. We want it to be pointing in the X direction. So right now it's pointing in the Y direction. So to change the orientation, first I made it float. Then I'm viewing the planes. I don't necessarily have to turn on the visibility of each plane. I'm just, for this example, just trying to make it really clear. So I have my assemblies planes visible. Okay, so I can turn on the visibility of the planes by clicking here. Next, I need to identify which faces to mate to the assembly. So the key idea is that we need to mate a parts plane, normally defined by a face, with respect to the assembly's planes. So in this example, what I'm trying to say is that I want to mate like this face to probably the right plane. So you can mate to the assembly's planes. And that idea really throws off some students, but I'll show you how you can do it real quick. So I'm going to go to mate. If I want it to point in the X direction, I'll probably want to mate this face so that it rotates. So I'll probably want to select this plane. So that's the right plane. So let's click right plane. And there we go. You see what happened? It rotated so that the right plane of the assembly, just right here, is now coincidental or touching this plane right here. And by doing that, it's changing the orientation of the assembly. So now this edge that we were interested in, it is pointing in the X direction. So I can control how my parts are oriented within the assembly by mating to the top right and front planes of the assembly itself. This is going to become really important, and I'll talk more about that in a minute. So before we get too far ahead of ourselves, let's go ahead and mate, let's say this, let's do the front plane. Okay. So there should still be 1 degree of freedom, so you can see it can still move up and down. So maybe I want to mate the top plane to say this face. And click OK. And now this assembly, it cannot move anymore, and none of the parts are technically fixed. That's because by mating to the top right and front planes of the assembly, the whole thing is now fixed in 3-dimensional space. Also, if I take a look at where the origin is located, the origin is now here on the assembly. So let's say I wanted the origin to be on this side, right here. Like, how would I change that? To change that, I'd have to go and edit my last mate that I did, this coincidental 14. So let's do that. So I'm going to go to edit. I'm going to clear my selection by doing a right click and going to clear. Next, I'm going to select the top plane again, and this time I want to mate it to this. Go. It's not quite what I was expecting. So, as you can see, sometimes Solidworks might try to do something like that. If that happens, I'm going to need to flip my mate, which I haven't talked about, but okay. Okay, so our goal was to move the origin. Actually, after that flip, I don't even remember where it's supposed to go. But the key idea is we can move the origin around based on how we made the particular components to the parts. So that last example brought up an interesting problem that we haven't talked about yet. So let's go and insert one more component, and I'll show you what happened. So I've inserted this L bracket. So I want to make this face to this one. Now when we mate two things together, the planes can be coincidental, but it doesn't necessarily tell us which direction it's facing. So sometimes it's not facing the direction that we want. And to fix that, we can click on this mate alignment. So it can be anti-aligned or aligned. So the difference is the normal direction pointing away from the part. So this part, the normal direction from like your geometry class, is like pointing directly out from the part. It'd be pointing up, kind of in the y direction. Whereas on this part, it's pointing down in the negative y direction. So that means that you can see in this little picture that one arrow is going up and one's going down. So that means that they're anti-aligned. the normal directions are not facing in the same direction. Let's say I want them to face in the same direction. If I want them to face in the same direction, I click aligned, and then it's going to rotate the parts so that the normal directions are aligned. This is a really common thing that we're going to do a lot within while modeling parts for this class. Okay. So back to our PowerPoint. So how do I place an oriented part? First, I'm going to look at the orientation simply by looking at the triad. Make sure all my parts can float. I'm going to view the 3 planes of the assembly and just think about how they're oriented with respect to my part. Identify which face I want to mate to the assembly's planes. I want to consider the placement of the origin, and then mate the assembly's planes. Now, the reason why this is important is, one, because we're going to give you homework that where the assembly is has the origin in a very specific location, and the assembly is pointed in a particular direction with respect to the origin, and also like certain parts are pointing in a certain direction, and you can figure that out by looking at this triad. Also, when you go to take the Solidworks Associates test, the CSWA, they're going to ask a question similar to this, where you're going to have to understand how you can mate to the top right and front plane to achieve the desired orientation within an assembly. So this idea of mating to the assembly's planes, I found to be kind of tricky for students, so that's why I'm trying to really hammer that home within this. So the last major thing is advice on how to put together an assembly. So the key idea is that we want to rotate and orient parts to nearly the correct position and then mate them together. This is in contrast to trying to orient or rotate, translate, and mate at the same time. So I'll show you what I mean. So in this example, let's say I want to mate these two so that they're interlocking. To mate them correctly, I need to mate this face to a face over here somewhere, and it happens to be this one. But to get there, I actually need to rotate the part in 3D space. Solidworks can do that for me automatically if I add the mate, and in this case it's maybe not that difficult for me to think about that or visualize that. But for more complex parts and assemblies, it can become quite challenging to rotate and mate at the same time. So my general advice is try to get the part in generally the correct orientation and then add the mates. So I don't want the part over here and be like, oh, I want it to mate it to this somehow. Then it becomes pretty tricky. So let's do that, or let's follow my advice. We're going to move component, rotate. I want to rotate it to generally correct orientation. Okay. Then I'm going to get it so it's kind of close. Okay, it's clearly not perfect, but it's much easier to realize then that this face needs to mate to this face. Like before, that may have been a slightly conceptual leap in our mind. Now that we have it almost right, I'm going to go ahead and mate it. So mate this one to this surface, this face to this face, and then this face to this face. And there we go. So again, the advice is to get them close to the correct position and add the mates. And that's because it's difficult to do all three at the same time. It requires excellent spatial, there's a spelling mistake here. It's just spatial reasoning skills, and it's difficult to perform. So simplify life and go one step at a time. So that's the basics about how to get started with assemblies. I've shown you how to insert components, mate to the top right and front plane of the assembly, how to make sure that you have your file system set up correctly on your computer so that the relative path doesn't change and when you go to zip and turn in a file, and also how to mate different parts together. And we're going to talk a lot more about this in the future. This is just the basics on getting started.